Plain concrete has compressive strength, that is the ability to resist crushing loads, and they have weak tensile strength, that is around 10% of its compressive strength. Its tensile strength is so low that it is nearly disregarded in design and most of the concrete structures. Now, reinforced concrete is a combination of adequate reinforcement and concrete that is designed to work together to resist the applied loads both in tension as well as compression. So here, this is a quick video on what is happening in a simple concrete beam and an RCC concrete beam, and what is the role of reinforcement in concrete beams or in reinforced concrete structures. A simple beam loaded in the middle and supported at the ends, as shown in the figure, will tend to deflect or bend down in the middle, which causes tensile stress at the bottom of the beam and tend to pull the fibers apart at the bottom of the beam. That is, the bottom of the beam is in tension. Reinforcing steel near the bottom of the beam will resist this tension and hold it together. Consider a beam that is supported in the middle and the ends are loaded, and it forms a cantilever beam. When you look, half of a section is being considered as a cantilever beam, such as a balcony. The top of the beam over the support is in tension and will pull apart or crack if there is no reinforcing steel near the top of the beam. So in cantilever beams, the tension reinforcement is provided at the top of the beam. This figure shows a properly placed reinforcement, that is the tension rebars in the cantilever beam, which is provided to resist tension and also control the cracking. This figure shows the incorrect placement or the missing reinforcement provided for a cantilever beam. There is no kind of reinforcement provided for the tension part of the concrete. So this is not effective in resisting tension, and this will allow uncontrolled cracking to happen in the beam. Among various applications of reinforcement in concrete structures, the main and the primary application of all the reinforcement is to resist the tension stresses or the resist tension that is happening in these concrete structures. Inability to resist tension is a major cause of structural concrete failures. If the tensile steel is not properly placed in the tension zone of a structural member, it will not be effective in resisting tension, and that will invite failures.